The parallel axis theorem describes the change in rotational inertia from when you have a known rotational inertia and you want to find a new rotational inertia using the same object but about a different axis. So the equation for this is that the new inertia, I new, is equal to the old one, or in this case we're using the one from the center of mass, plus the mass of this object times the distance between the two axes squared. And these axes have to be parallel. Like, say I wanted to rotate this pen, or this mascara, sorry, I picked up the wrong thing, and initially I was rotating it about this axis right through the center there, and I wanted to see what my inertia would be rotating it right through an axis right here. I couldn't do that using the parallel axis theorem because the two are not parallel, but I could see what it was like, what the inertia would be rotating it about a different axis on parallel to the other one, say one going through right there instead of in the center. So in problem 19 of the AP exam, we have a solid disk of mass m and radius r, which is freely rotating horizontally in a counterclockwise direction with angular speed about a vertical axis through its center with negligible friction. The rotational inertia of the disk is mr squared over 2. A second identical disk is at rest and suspended above the first disk with the centers of the two disks aligned. As shown in the figure above, there is no contact between the disks. The second disk is dropped onto the first disk, and after a short time they rotate counterclockwise with the same angular speed. So this is an image of what's going on, and that top disk is being dropped on the bottom. So the disks are now shifted so that the axis of rotation goes through a point on the edge of the disks. The rotational inertia of the two-disk system is now. So the initial rotational inertia of the system would be 2 times the rotational inertia of one of the disks, because there are 2 in the system. And we know that the rotational inertia of one of the disks is mr squared over 2. So the rotational inertia of the whole system at its center of mass, as shown in that image, is just going to be mr squared, like this. So from there we want to find the new rotational inertia, and we can do this by adding this initial one, which is mr squared, plus the mass of the objects in the system times the distance squared. So that would be the mass of the objects in the system is going to be 2m, and the distance between them is going to, between the two axes that we're looking at, is going to be r, so we need to take r squared. So this is our equation. That first part is the initial rotational inertia, and the second is what we have to add to it to use the parallel axis theorem. So from there, we can just simplify this all out, and we see that our new rotational inertia is going to be 3mr squared. And just like this. And I realized I wrote a lot of my exponents as subscripts, but those are all meant to be exponents. So our answer is going to be B on the AP test.